So we have tangent lines. Tangent lines is new. 10.5 tangents. A tangent line is a line that touches a circle in one spot. Now, the only way to touch a circle in one spot is for it to be on the outside of the circle. Because if I was a line and I went through a circle, here's my circle, okay, and I went through it, it's going to touch in two places because it's going to come in and then it's going to go out. So a tangent line is on the outside of the circle. So that's like my line that's my tangent line. So a tangent line intersects a circle at exactly one point. That point is called the point of tangency. So looking at your picture, what point is my point of tangency? Is it A, B, or P? Point A. That's you. So point A in that picture is my point of tangency because that's where it touches. A line is tangent to a circle if and only if it is perpendicular to a radius. So in your picture, there is a right angle right there because your radius is intersecting with that line at a 90-degree angle, which means that it's touching at one spot, specifically one point. It just like grazes the circle. We're going to skip 1. Let's skip 2. Let's go to 3. So 3 says that JK is tangent to the circle. We need to find X. Pythagoras, he's back again. Because this is making a right angle right here, the opposite side is going to be C. It's making a triangle. So we're going to use Pythagorean theorem. So we're going to do 7 squared plus 19 squared equals C squared. It's like you can never get away from him. He just keeps coming back. Yes, that is correct. This one's nice because you just do it in the calculator. Just square it, add it, square root it. So you get 20.2. And that's actually representing the whole length. So X and C are exactly the same. So 20.2. Yes. Why does it have to be squared? I don't know. That's a great question. I don't know. Yeah, you would get a different answer if you don't square it because then it'd be like 19 plus 7 square root. It'd be really small. That's a great question for Pythagoras, but I'm not Pythagoras. We just follow what he says. We're like, aye, Captain. Let's go to 4. Same idea. You have a right angle right here where the point of tangency and the radius meet. So C is across from that. So on the opposite side of C. Okay. C is not 7. We have 11. We have X. So we have 11 squared plus X squared equals C is the whole thing. It's not 7. 7 is this little piece.
Yes,
Huh? Not 14. Not 11.
Oh, 18.
Oh, yeah. Yeah. Okay, Fabio, how'd you get that?
The radius.
The radius. Okay, so good old radius. He moves around in a circle all the way around. So if this is 11, then automatically this is also 11. So C is going to be this whole thing added together. So C is actually 18. Nice. Big brain. Okay, so you're going to have to think outside the box a little bit. So same process. I'm going to do 11 squared plus X squared equals 18 squared. This one's a minus problem. Mm-hmm. 18 squared is like 3 something. 324 minus 121 minus 121. So X squared is 203. So when you square root it, what do you get? 14.2. How do we feel? Feeling parched? Oh, yeah, go ahead. Okay. So So like I said, this is not like a straight to it Pythagorean theorem. You just gotta think a little bit more. Okay, so let's look at number 5. What are we thinking? Your right angle. Okay, C. Yep, C is across from it. Is X that whole distance? No. What's gonna be this piece right here? 10. Because if this radius is 10, then automatically this one's also 10 because radius goes all the way around. So what we're gonna do, we need to find this little piece. So we're gonna find the C like normal. And then to find X, we'll just take 10 away from it to represent that length. Okay, so let's do 10 squared plus 24 squared like we normally would. I'm finding C, the hypotenuse, just like a normal Pythagorean theorem problem. So how much is C in total? Was it 26? Okay, so that's 26. Now, how much would X be if all of C, the whole distance, is technically 26? X would have to be 16. Because if this radius is 10, then X would have to be 16 to make a total of 26. So some of them just have like a little extra step at the end where you may have to add, you may have to subtract, you might have to like divide by 2. Okay, so we'll take a second, look at number 6. 6 isn't too bad.
Is X the whole?
X is this whole thing, yeah, that's like, this is like normal. This is your right angle. Am I using 11? So because 11 represents the radius, 11 can also go here. So this whole distance is not 11, it's going to be 22. So we're going to use 22. We're going to use X. And our hypotenuse is going to be 25. Because it's a radius, it goes from the center out to the circle. So if this piece is 11, this is also 11. So it doubles. I know. I think this weekend went by so fast. Okay, so if you find X, what do you get? 11.9. Okay. So take a second, look at 7. Seven and 6 are very similar. What are we gonna have to do for 7?
Is J the right?
J is the right angle. 6.4 is fine. I can't use 3.5. How much am I actually using for this whole distance? Yeah, so this whole distance will be 7. So I'm doing 7 squared plus 6.4 squared equals C squared. And that one, I don't have to add or subtract or anything. It's just like Just gotta double the 3.5 because it's double like. Nine point five. Me? How we feel? Okay, let's skip 8. Let's skip 9. Let's skip 8. Let's skip 9. No. Okay, so the next thing with tangents, so tangents you can do right triangles, you could do the Pythagorean theorem with. Or that's if you have like one tangent line and then you have a triangle inside the circle, kind of making a right angle. Okay, so the next thing with tangent lines is more properties of tangent lines. I call them party hats because they remind me of a party. Because like, you know, like that looks like somebody's head and they're like wearing a party hat and it's like they're falling. Or like this one, there you go. There's your party hat. So I call them party hats. This is on the EOC. Okay. So for your party hats, basically, and you should have enough common sense to look at this. Like if you're just looking at this, if I just gave you this problem, what would you might think to do? Equal them to each other because they look equal. They are equal. So the theorem goes that if you have one tangent line going this way and you have one tangent line going this way and they intersect, okay, so here's my head, here's my party hat, then they're equal pieces. And that's why I call it party hat because whatever the length is on this side is going to be the same on this side, okay? So they're equal to each other. And then you can have multiple party hats. That's whenever it's like a real party. And then you have them like going all the way around your head, okay? But they're still like this one's equal and this one's equal and this one's equal. So we'll get to that in a second. So we're going to set these equal to each other. This one's just finding X. This one, we're going to do the same thing. We're going to plug it back in. This one's on your EOC. You're going to find X, you're going to plug it back in. Easy peasy. That should be an easy question. Everybody gets correct on the EOC. But you would be surprised. You know, equals, stuff happens, you know. It is what it is. Bless you. So take a second. We're going to add 19 because I don't like the minus sign. So like, why not add instead of subtract? And I'm going to minus 5. So 42 equals 3x divided by 3. So what's x for this one? 14. Easy peasy lemon squeezy. So try 11. Only difference is you will actually take that answer and substitute it back in to represent the length of the hats. Bless you.
That's on number 8.
8 and 9. You're learning a lot today? Wait, what?
Nothing.
Just talking to talk? Fair enough.
So tired.
What?
I'm so glad lunch is right after this.
I like things go very fast. Yes. No, those are sine, cosine, tangent. Okay, so for 11, what do you get for x? 3, and then you plug it in to find PQ. So if you do 14 times 3 minus 20 minus 13, what's PQ? 29. Those are not too bad. Okay, there's gonna be a million things that you're gonna try to remember for the EOC. That's like a common sense. They look similar. They look the same. They are the same. Okay, let's skip 12 because those are not bad, right? Let's go to 13. So now it's a real party. So we have parties going all the way around our head. We have party hats, party hats, party hats. So party hats are equal to each other. So if I have 16 for HE, can I put 16 at DH or can I put it at EI? EI. So this one matches this one. If I have 9.5 here, I can put it on the other side as well because that's a small party hat, but it's still a party hat. And then I have 11. 11's going to match over here. The whole point of this problem is to find the perimeter of triangle DEF. If I'm finding the perimeter, you're adding up all the sides. So I'm going all the way around for this triangle, which is the whole shape. And I'm adding them all up. So 11 plus 11, 16 plus 16, 9.5 plus 9.5. So you're adding each number twice. So what do we get for the perimeter? 7 to 3. It's going to be the same thing for number 14. 14, party hats match party hats. So if I'm looking at this one, is 37.5, does that represent a party hat? No, that's a whole length, so I cannot match that anywhere. 23 is a party hat. 23 represents the other side of the party hat, so 23 can also go here. So this involves like one extra step. If that's 23, what am I going to do with 23 and 37.5? Subtract, because I need to know how much this itty bitty little tiny baby party hat is. So if I subtract them, how much is left over? 14.5. So 14.5 can go there, which means 14.5 can go here. 27.1's there. 27.1 can go here. So how much is the party hat where S is at? 25.4, and that matches on the other side too. And then what are you going to do with all those party hats? Add them up. So take a second. You're doing 23 twice, 14.5 twice, 27.1 twice, 25.4 twice, and adding it all up. It's big, it's large, it's in charge.
Me too.
Anybody? 180. So this is ironically, it's not because like there's a triangle or anything. It's just ironically like 180. So don't think too much into it. Okay. So on the back, I don't want you to have to do the Pythagorean theorem a million times. I don't think it's like really worth it to do it a million times. So we're going to cross out a bunch. So that way you don't have to do like Pythagorean theorem a bunch of times. Okay. Just a little practice. And then that way, when you're done, you can turn this in. And then you can start working on the EOC review that's due Thursday. This says 10.4. It's not 10.4, it's 10.5, but that doesn't really matter. So you can skip number 1 through 4. You can skip 8. You can skip, what else did I skip? 11, 14, and 15. Okay, I don't want you to do like a bunch of them because it's kind of pointless. I don't think this is terrible. Doing the Pythagorean theorem, you just might have to think a little bit. Let me know when you get stuck. I'm going to pass out papers. The papers pass out. I was supposed to do that last week and I forgot.